quadratic graphs and their properties. The big idea is a quadratic is a function that can be written in the standard form y equals ax squared plus bx plus c. And we're going to take a look at this. Actually shows the parent function of y equals x squared, and you can notice that there is an axis of symmetry there. That's that line that goes up and down, and then we also have a vertex that we need to pay attention to. And the reason why I chose the song today is because we need to remember how or which direction your parabola is going to actually open up. And so the easiest way to remember that is by the a term. If the a term in this polynomial is going to be positive, then your parabola opens upward. It's like a room without a roof. And then if it's negative, it's not going to be happy. So it's going to open downward. So positive a term, your parabola is happy. Negative a term, it's not happy. Very easy way to remember that. There you go. Ladies and gentlemen, the vertex of your graph is going to be this little piece right down here where it basically comes to a point and then stops and turns and goes back the other direction. So that's the vertex of your graph. So in this one, in number 1, we need to label what our vertex is. So what we do is we actually label that as its point. So it's going to be 1 on the x-axis, 2 on the y-axis, and that right there is how we label our maximum or our minimum. And in this particular case, it is the minimum point on the graph. So we actually write that it is a minimum. Okay, and so that's pretty much all that we need to do on number 1. So as we move on to number 2, again we're going to focus on this point right here. It's called the vertex. It's where the graph comes up here and boom, hits that spot and turns and goes back down the other direction. So in this particular case, it's at -1 and 4. So we're going to go ahead and state where our vertex is by that ordered pair there. And we're also going to call this a maximum because that is the maximum point on. Ladies and gentlemen, I decided to go ahead and type because my handwriting is so awful. I didn't want you guys to be messed up because of my handwriting. So there we are. We have on number 1 and number 2 our minimum and our maximum. Wanted you to see that more clearly, and there we have it. Folks, your notes actually skip around quite a bit, so we're going to go on to number 3. Please find the right spot on your notes. What we're going to do on this one is we're going to actually make a chart, so that way we can figure out what our x values are going to be and what our y values are going to be. So that's what we're up to. Alright folks, you can see our table of values here. What we had to do is basically take all of these x values, plug them into our function, and it gives us y values here. So now we can actually take and plug those points onto our graph. So we've got -2 and 12, which is going to be right up here. Alright, we've got -1 and 3, so that's going to be right about there. We've got 0, 0, or the origin. We have 1, 3, and we have 2, 12. Then we go ahead and graph this puppy. It's not a puppy, it's a parabola. And it's a happy parabola. It's going to open upwards. There we go. Hopefully when you draw your parabola, it doesn't have some bumps and bruises like that one does. However, I think you get the picture there. Next, we want to figure out what our domain and what our range are going to be. So, our domain is going to be all of the possible x values that could happen on this. So if we were to go all the way to infinity, we would actually include every single, this is just going to get wider and wider, and we would actually include every single x value to negative infinity, and the same thing to positive infinity. So we would we would get all real numbers. And so that's what we would write for our domain. All right, so for our range, basically, it's going to be all of the y values that are possible. So this is the minimum of the point, 0, 0. That is the minimum y value that could possibly occur. Everything else must be greater than 0. So what we're going to do is we're going to say that y has to be greater than or equal to 0. And that takes care of our range for that. Move on to number 4. So make sure that you're plugging in this information in the correct place on your notes. But we're done with that disclaimer. So here's what we're going to do. It's kind of the same process as number 3. So we're going to create a table. You guys have done this before. You know what to do. And we're going to plot some points on our graph. Y value. And I'm going to change color. That way we can see it a little better. Let's go ahead and use some of those similar points that we've used in the past. -2, -1, 0, 1, and 2. So this one's going to show some of our work. You may have been working ahead of me a little bit there. So we're going to have -2 squared, which is 4. 4 divided in half is going to be 2, and we have a negative out front, so this one's going to be a -2. Then we have -1 squared. That's going to give us 1. 1 divided in half is going to be 1/2, and that's a -1/2. 0 is just going to be 0. Then we're going to have a 1 squared, so that's going to give us 1, and we're going to have a negative in front again, so it's a -1/2. And then we're also going to have a -2 for that one. So now we can move along to graphing. Here we go. -2, -2. So our graph is going to go right there. I went the wrong direction. I went the right direction on my x values, but not my y values. -2, -2. You guys aren't sitting here to catch me on my mistakes. Got to catch my own. Then we're going to have -1, -1/2. So that's going to be kind of like there. And then let's do 0, 0. I think you guys kind of get the picture of what our graph looks like. So let's change colors again. And have this parabola go ahead and open up. So this one has a negative for our a value, so it opens up down. And we also need to, part of our instructions for this one was to identify the domain and the range. So our domain on this one is going to be all real numbers. And our range on this one, that's our y values. Again, our domain is our x values. Our range is our y values. So we have a maximum of 0, 0. So on this one, y is going to be less than or equal to 0. And there you have it for number 4. All right, folks, I took a look at our time, and I'm running out of it quick, so I went ahead and did quite a bit of the work on that problem for you. Feel free to go back and check it, though. I would love for one of you to find one of my mistakes. Okay. I don't know why, I kind of like to find where that vertex is going to be and plug that in, so I'm going to start with that. Our values are going to be -2, -5. 1, 2, 3, 4, 5. Okay. Then we're going to have -1 and 1. So right there. The other side are going to look very similar. In fact, that they're reflected there. So here's what our graph is going to look like. It's a parabola that opens downward, and we know that because we have a -a value. Okay, it'll look something like that. Terrible looking, but I think you get the picture. That's how we do number 5. And oh, we also have to include our domain and our range, which our domain is going to be all real numbers. And then our range is going to be all of the y values. So our y values are basically going to be everything less than 3. So that's exactly how we're going to write that. Y is less than or equal to 3. For number 6, please pause the video and try it on your own. And we're going to come back here in just a second and see if we got the same answers. Folks, hopefully you paused the video like you were supposed to and did your work. This is your chart of values that you should have gotten for x and y. Your domain should have been all real numbers. Your range should have been y is greater than -7. Your graph should have looked something like this, only hopefully your graph looks better than mine. My graph doesn't look very good. These are supposed to be curves that slowly get wider and are actually following a path that doesn't have bumps and bruises along the way. So let's move on to the next one. Number 7. As Mr. Hale walks along the Golden Gate Bridge, he drops a quarter to Mr. Thornburg. He must need to make a phone call. Who is swimming in the bay? The bridge is 220 feet above the water. The quarter travels at the pathway y equals -16x squared plus 220. How long does it take the quarter to hit Mr. Thornburg? Here's a hint. Use Desmos. I love Desmos. In fact, I've already plugged it in for you so that you can see exactly when it's going to fall off of the Golden Gate Bridge, the quarter that is, and hit Mr. Thornburg. Hopefully it hits him in his hand and not his head, because that's quite a fall. It might hurt. But x is going to represent time. So this is going to be about 3.71 seconds. And that is that's about how long it should take until it hits him. Number 8, Mr. Meyer is modeling free fall situations with his physics class. To do this, he climbs a 150-foot tall flagpole and drops a baseball. The height of the ball is given by the function h equals -16t squared plus 150, where t represents time in seconds. Graph the function. You can do that on Desmos. It will look extremely similar to the graph on the previous problem. And also, how far does the ball fall from t equals 0 to t equals 1? What we're going to do on this is we're going to plug in 1 second into our function and see where it ends up. And I wasn't trying to hit that button, I was trying to hit that button because I had basically done the math for you. We're running out of time. We need to go a little quicker. Basically, the ball is going to fall about 16 feet in that first second. And then part C, does the ball fall the same distance from t equals 1 second to t equals 2 seconds as it did from t equals 0 seconds to t equals 1 second? So, to figure out that one, we're going to also plug in 2 seconds into our function to see where it's going to be. So this 86 is going to give us the point on the graph, if we were looking at it, of where the ball would be. So that tells us this. In the first second, the ball is going to fall 16 feet. In the second second, so from second 1 to second 2, the ball is going to fall farther. It's going to fall another 48 feet. Okay, so the answer to C is no. The ball is not going to fall the same distance in that second as it does in the first. Ladies and gentlemen, that is the conclusion of your 9.1 notes. Thank you very much for joining us. And I can tell you that I am happy that our video is done in under 15 minutes. See you in class.